What do you do when you want to take the derivative of a quotient of two functions, right? F of x divided by g of x. Well, this is the quotient rule that you guys are all taught. And this right here is actually kind of complicated, kind of nasty. So where does it come from, right? Like, why are you plugging in random numbers to random crap in here? Well, we can go ahead and derive it. But we're not going to use the definition this time because that's getting boring. Instead, here's what we're going to do. We can rewrite this guy as this. We can just take f of x and then multiply it with 1 over g of x. Because what really happens here, right, is that the f of x is simply multiplies with the numerator, and it just becomes that. I think that's pretty basic. You can now also rewrite 1 over g of x as g of x to the negative 1. So here's how that's going to look. G of x. Now we raise it to the negative first power. And that works because, raising anything to a negative power just flips it down to the denominator, right? So now that we know both product rule and chain rule, I think we know what to do next, right? This, we just converted that quotient into a product of two functions. So we can go ahead and apply product rule. Take the derivative of the first function. You get f prime of x. And then let the second function stay. So you still have g of x to the negative first power. Or, in other words, 1 over g of x, right? Kind of the same idea. You add on. Now you let this first function stay. So f of x remains unchanged. But now you got to take the derivative of the second function. So what is that? Well, first notice how you have an exponent, right? That's what's happening on the very outside. This g of x is on the inside, right? Because this negative 1 is being applied to the whole of g of x. So the negative 1 is on the outside. So, according to chain rule, we have to take the derivative of the outside function first. We take this guy, we drop it down to the side using power rule, right? And then the inside is going to stay the same, so it's still going to be g of x. And then we subtract 1 from the power. So the power goes from negative 1 to negative 2. And then what you do next is multiply by the derivative of the inside function. And in this case, our inside function is this g of x that's sitting inside of this to the negative 1 here. So this g of x right here is the inside function. And what's the derivative of g of x? Simply g prime of x. Right? There you go. Close the outside parentheses. Next, we just have a massive round of simplification. So, I want to deal with this guy first. It looks kind of simple. f prime of x, we can write it as the numerator, right? Because what is g of x to the negative 1? It's just, this guy right here is just 1 over g of x, right? If we do f prime of x, multiply it by 1 over g of x, then it's going to be this guy over g of x, right? You're going to have f prime of x over g of x for the first term. Next, the second term. See how this negative 1 is multiplied? Well, we can go ahead and just take the negative out here and make it a subtraction. And I'm running out of room, so I'm going to get rid of that. So we're going to use this negative 1 and make it a subtraction right here. We have this f of x. And I'm going to deal with this g prime of x first, because those two multiply. Now, let's take a look at this guy right here. G of x to the negative 2. Well, what does a negative power mean? It means you flip it into the denominator, right? So you get 1 over g of x. But it's still to the second power. So this guy, we can go ahead and replace that with. We can go ahead and plug that in right here, right? This is the same thing as multiplying by g of x squared. Except, once again, these two functions multiply into the numerator. So we can kind of just put this g of x squared guy into the denominator. Like this. Alright, finally, notice how this entire thing right here is just one fraction. Well, I want to make this guy one fraction too. So what's the least common denominator? It's just g of x squared, right? We don't need to touch this second term right here. All we got to do is, for this first term right here, multiply g of x on top and a g of x on the bottom. It's just multiplying by a big ass 1. On top, what's that going to get you? That's going to get you f prime of x times g of x. And on the bottom, that's going to give you g of x times g of x is just g of x squared, which is now our common denominator, right? So this now becomes g of x squared minus f of x. We just put down the whole term again, right? F of x times g prime of x over g of x squared, like that. So finally, we can go ahead and combine the numerators. So we get, let's copy this down first, and then we subtract off this other term right here, like that. And then the common denominator here, as we saw earlier, is g of x all squared, like that. So that's where quotient rule comes from. You just break up your quotient into a product and then use product rule. And also notice here that you need chain rule. So yeah, and then after a bunch of simplification, that's what you get. You get to the quotient rule formula, right? So that's why quotient rule is the way it is, and that's why it looks so horrific. Yeah.